I personally took the October 2025 ACT math section. There were some challenges, there were some easy questions, and there was some changes to it as well. So this video is a walkthrough from the released October 2025 math test. This is how I personally solved it. I'm going to be putting in some calculator hacks as well. So go ahead, get out a pencil, paper, and your calculator, and let's get to work.
Okay, so in this walkthrough, we are going to work through all the problems. There's going to be some also overlay of how I do it on my calculator as well. Just please note there's more than one way to solve a couple of these problems here, but this is a little bit of your walkthrough how to do it. So on number one, we're going to start nice and easy. What is the solution of this equation? It's square root of x minus 9 equals 8. This one is easily a guess and check on the calculator, making sure you use the square root button. But on this one, if you just put the square root of 289, it's going to be 17. And let's change that size. Minus 9 equals 8, and that works, so that's going to be D. Number two is a big calculator problem. And this one you can put exclusively in your graphing calculator. So on this one here, you just have to type in exactly what it says on your graphing calculator with the parentheses to the power of, I like putting decimals, so I just go negative 0.5 and you go enter, and the answer is going to be 8. So on number three, for which of the following fractions does the decimal expansion require one repeating non-zero digit? People get really kind of spud up with this, but all you are doing is putting it in the calculator and you're looking for one repeating digit, which just means number. So if you put this in the calculator, and most of you guys might be able to eyeball this, but knowing that 2/3 on the calculator is going to be 0.66666, like forever, the answer is going to be D. So on number four, when a fair coin is flipped a large number of times, the number of heads should be approximately equal to the number of tails. Assume that the fairness of a particular coin is being investigated. Which of the following results provides the strongest evidence that the coin is not fair? So here's the thing. If you look at percentage, like F is going to be a bigger percentage, but that's not a lot of testing. And if you think about in testing, you want to have more volume or just more times that you test it. So on this one, the answer is going to be J, just because of the number of tests or flips. Okay. So on number six, so on number five, Anna plans to save 200 for a summer skate park pass. She already has $45 and plans to save 15 per week. At this rate of savings, what is the minimum number of weeks after Anna will have enough money for the skate park pass? So she needs $200, and then she already has $45 and needs to save and can save 15 per week. And then this I just did quickly in my calculator. In my calculator, I went 200 minus that 45 and then divided by 15. This one's a more logic based. So what you get on your calculator is a little bit of like this crazy 10.333. Now, if she only did 10 weeks, she wouldn't have enough money. So this one you have to do B11. Okay, on number six, similar triangles really mess up students, but what you need to know with similar triangles is that they have the same, and this is answering, same angles, but different sides. Okay, so on this one, I pretty much just answered the question. Similar triangles must have the same angle measures. Okay, no, on number seven, which of the following expressions is equivalent to this particular one here? So on number seven, you just have to FOIL this out. And then, so what that means is you would go 3x minus 9, parentheses 3x minus 9. And you're going with the terms first, outer, inner, last, which should be a review. So that would be 9x squared. And then if you combine these two, that's negative 27x outer. And I kind of did it backwards, but it's okay. And then negative 27x. And then the last terms is negative 9 times negative 9, which is plus 81. Once you combine like terms or just do a quick look, the answer is going to be H. So next year, there will be 3,432 high school students in a certain district. Each of these students will attend either the East High School or West High School, but not both. Both facilities, the ratio of number of East High School students to the number of West High School students must be 11 to 13. And a lot of students I've worked with on this really have struggled with this problem, but it's not too bad. How many students will attend East and West, or pretty much East High School? So the way you do these, and they love these ratio ones, so I'm going to make a little chart. So you've got, I'm going to go EHS, and then we'll do WHS. And then the EHS is 11. And then the WHS is 13. So actually the kicker is you just go 11x. You just slap on an x. So I would say plus 13x equals 3, 4, 3, 2. And then you go ahead and solve for x. 11 plus 13 is 24. And then 4, 3, 3, 2 divided by 24 is going to be 143, but you're not done yet. And they have a little bit of a trap right here. So then since you're going to East High School, you have to plug it back into that 11 or 11x. So then you go 11 times this number. That's going to be 1573. And that's the answer. Some students haven't been able to actually eyeball and just answer it, but I'd rather just show the mathematics behind it if I can. So on number 9, you've got a lot going on. So you've got the hourly and the first 40 hours he works in 1 week. For each hour over 40 hours he works in 1 week, he earns time and a half, which is actually pretty standard. Which of the following gives the amount in dollars this worker earns for 54 hours in 1 week? So the key is he's making those 40 hours at that $20.10. And then he's making those extra hours at time and a half. And the only one that makes sense is J because of the breakdown of this equation. So number 10, for the complex variable Z, one of the following solutions, or which one is one of the following solutions here? So I've kind of done it both ways. So and I've had students stuck with this. For most students, especially if they're strong with imaginary numbers in Algebra 2, if you are simplifying one of these square roots, you're just going like that. And then that's automatically going to flag that you need an imaginary number because you do not put a square root over a negative. So if that's not natural to you, what I have some students do to remind themselves or to remind themselves is actually just type it in the calculator, which for some people that would be silly, but for some it does help. So all you have to do is you go second, square root, and then go ahead and type that -9. Doesn't give you the answer, but non-real answers. And then at that point, you're like, oh, imaginary numbers. So this is why on this answer, this one is 3I. Okay, so a student modeled a set of paired data with the equation of this right here. The student's model, there's a lot of fluff in here, so let's focus on this. Among the following possible changes to the student's equation, which one will most improve the fit of the paired data? So right here, you've got this line, and then you have all this data up here, so we just need to increase the starting point. And so if we go by this, increase the slope, which would just make it go up more, then maybe. That's just going to make it a little steeper. And then you've got on this one, decrease the slope, and that would make it go down more. That's definitely not right. Increase the y-intercept, which is that intersection on the y-axis, by 12.5 or decrease. So we know it's not going to go down. Likely the best point is actually just to go up through there because the slope is actually pretty good and the y-intercept is the problem. So this one is going to be H. It's really important that you know y equals mx plus b. If you look in the description of this, we will link our massive packet that has like formulas and ACT, like math and the calculator programs, all of that. And we're gonna link it below if you want to download this before your ACT exam. Okay, so number 12, a certain committee is composed of 11 juniors and 79 seniors. Two different members of the committee will be randomly selected, each for a different leadership role. Given that the first member selected is a junior, what is the probability that the second member will be a senior? So we've got, I always like to make a little chart. So we've got 11 juniors. Let me erase that. Okay, so we've got 11 juniors and then 79 seniors. So what happens is, given that the first member is a junior, so now they're down to 10 juniors and 79, what is the probability that the second member will be a senior? So all you have to do is you add these up. So we've got 89 left, and then we've got still 79, which is going to be C. So on number 13, this table lists the engine sizes. A linear model is this right here. It is so important to know about y equals mx plus b, what you're identifying, and that's always going to be the slope and why it matters. The actual weight of the vehicle with the smallest engine size differ from the linear model's predicted weight of this vehicle by how many kilograms. So what they're saying is this is the theoretical model right here. And then this is the actual. So all you have to know is what you put in for X is what matters. So on this one here, it's saying the smallest engine size, which is going to be 2. So what we're going to do is we're going to plug it into here. So then we go W equals 375, 2 plus 370. So you have 375 times 2 plus 370. That's going to be 1120. And then here's your actual. So you're going to go 1041. And then that is going to be 79. Okay, so on number 14, this has messed up a few students, especially in our school group, which we have linked below. We've been working on these live together, and we're about to do a monster review. On this one, the given length of function, distance C, it took a total of 13 minutes to hike. Let me make sure we're good. Restarting in 3, 2, 1. So number 14, students have really overthought this, especially with the brackets here, but this is how you break it down. So you have this graph here, left to hike on a trail of T minutes since the beginning of the hike. It took a total of 13 minutes to hike an 860-meter trail. One of the following intervals is the domain of the function. And remember, domain just equals X. And just a reminder, range equals Y. So which one is it? So we have 0 and 13. Those are the only answers right here. So it's A. So on 15, whenever you see imaginary numbers, these are freebies. You want to go ahead and plug it in. In the description, we'll link our free TI-84 calculator hacks that are really helpful to know in the ACT and actually the SAT if you're taking both. So on this one here, you have to put it in verbatim, but here's the kick. And then I'm going to show you on this. You have to put in the parentheses. If you are doing these type of fractions and all that stuff, please put in parentheses because your calculator is not that smart. So what you do is you go 10I plus 2 divided by parentheses 2I, hit enter. It's going to be 5 minus I, and then you get to move on. That is definitely a freebie right there. So at number 16, there's technically a built-in program on the TI-84, and I have that linked in that mega ACT and SAT packet below. But this one I actually prefer to solve by hand, to be honest. This one's just a little bit easier, but some of them would be easier to use in that program. So this one right here, you're going to use substitution. And what you need to do is we are solving for X. So what we do is we isolate this. So what we're going to do is get y by itself, which will be y equals -8, x plus 6. I am just moving that x there. And then now we're going to plug it in. to find our x. So in this problem, it would be 9x minus 6, negative 8x plus 6 equals 11. So on this one right here, you're going to go ahead and distribute 9x minus, that would be plus 48x minus 36 equals 11. And then you combine a like term, so you're 9 plus 48. 9 plus 48 is going to be 57. X, and then on this side, you're going to move that 36. 36 plus 11 is going to be 47. So X is going to be equal to 47 over 57. And if you're thinking this is a little bit slow for the test, I am moving a little bit slower just because I'm doing a little more extra steps. I'm explaining it out, but a lot of these can be done a lot faster. Okay, so 17 is one of those that some people eyeball really well. But on the flip side, personally, I love relying on my calculator programs for this one, and I will make sure to include that and pop it up in this recording in this video. So on this one right here, a lot of people just freak out when they see it. One, they just don't remember, or some people just haven't seen it before, and that's okay, and it's not the end of the world, but I'm gonna kind of give you some easy hacks for it. So with these type of problems here, what you need to do is you need to focus on first that front number right there. That number in front of either the sine or a cosine graph is always going to be your amplitude. And so that's an easy way without really mathing to go ahead and narrow some options down. So we're going to go ahead and remove B, and we're going to go ahead and remove D. Now we're down to period, which tends to mess up a lot of people. And this is where I will pop up how I just pretty much punch it in this program, and these are also downloaded, link below with the mega packet. But in general, if you are kind of stuck on these two and you're deciding between a period of 1/3 or you're deciding between a period of 3, what you are pretty much looking to do is simplify that front number and the bottom number and like pretty much divide, and this one is going to be 1/3. I have some people that have really done well at like eyeballing it too. That is not my favorite method. Honestly, I feel better, especially in a speed game, always plugging it into the calculator. So on number 18, they give a lot of craziness, but you just have to narrow down what they're asking. So which of the following gives a solution to this? And what you need to know is what they're actually solving for, and this is let x be a variable. And if you see all of these do not have an x in them, so they're solving for x. And so this is how the best way to do this one. So you go C, x minus h equals q. And then you are going to go ahead and distribute cx minus ch equals q. Let's go ahead and try to get x by itself equals ch plus q. And then we will go ahead and divide by c. And of course, on this one, that should go ahead and cancel out. And so we're to h plus q over c, and 18, the answer is going to be G. These look way harder than they actually are. Okay, so on number 19, given that triangle RST, you've got the side links. Which of the following statements is true about the angles of this triangle? So honestly, you got to draw this out. So we got RST. RS is going to be 18. And then you've got ST is going to be 12, and then RT is going to be 27. So one thing you have to remember in math is the longer the side, the opposite angle is going to be the biggest. So before I look at these questions, S is going to be our biggest angle, and then R is going to be our smallest.
So let's look at these options. So it says R is the least on number 19. That seems like a good one, but let's double check our other options, which is just good testing practice. The measure of angle S is the least. That's wrong. The measure of angle R is the greatest. That is wrong. And the measure of angle T is the greatest, which is wrong. So it's A. Okay, so in number 20, you've got inverse functions, and these tend to trip people up. All you have to do is inverse is opposite. So the rule is to swap the x and y. So how this looks here is you have your equation right here, and remember f of x equals y, and so then you rewrite it. You go x equals 2y minus 5, and then you go ahead and solve, because none of these have the y, you go ahead and solve for y. So on this one, what you will do is I'm just going to move x to this side, and then you just divide by 2. And so this answer on number 20 is going to be G. So on number 21, this one intimidates a lot of people. So what we're going to do is we're just going to try to simplify and do process of elimination. So we have a circle is stuck in a square, and we know this part right here is going to be 8. And then we also know that this part right here is going to be 8. And then the other things that we know is the diameter AB is parallel to 2 sides. That means we've got some similar triangles, and then diagonal. But a lot of this you can do through, honestly, you can do through guesstimating. So kind of just looking at it from here is you want to figure out a ballpark of what this diagonal is going to be to find out this. What you can also do is find the area of the circle and do process elimination, because what we're actually finding is which of the following is the closest to the total area of the shaded region. So let's go with area of the circle. So we go pi r squared, so we go 8 squared, and we are of course going around 3.14 times 64 is going to be about 200.96, and that is just the area of the circle. And then there's probably even if you ballpark it a little bit, just looking at the edges here, that is going to at least cover close to 100 points. So what I would look at this is shaded is almost the entire thing. So I would eliminate A, I would eliminate B, and now you are down to these two right here. Honestly, you want to hit the middle ground, which is going to be C, as a pretty much a process of elimination. But if you want to get nitty gritty about this, let's go ahead and do it at this point. So what I would do is I would start looking at the circle, and there's more than one way to do it. This is just the way that I prefer. So looking at the circle here, we've got opposite angles, and then these are actually going to be equal to each other. So let's see what parts we have here. So we have an 8 right here. We have an 8 right here as well. And then we can pretty much try to figure out a little bit of the area of the sector. So I would actually ballpark this pretty hard. And that's what a lot of people do not talk about, is that you can make a lot of assumptions on this test, on the ACT. So if we just divide this into different sectors, this is probably about 45 degrees. So right here, 45 degrees of 360 is about 2.25 or 12.5%. And if we just take that of this right here, that right there is going to be about 25 to subtract from the whole area, and that is going to be even less. And then if you're like, okay, what is the whole area? So the whole area can easily be assumed by actually just this circle inscribed. and you can comfortably call this 16, and you're like, yeah, you're making assumptions, and I am, and that's kind of the easiest way to go about it. So you go 16 squared, so the whole area is 256. So your most logical answer is 224. Okay, so on number 22, let's go ahead and get started with that one. So in the standard XY coordinate plane, a certain dilation maps out the point 0, 0, and itself maps the points for -16. There's a lot here. This dilation maps the point 2, -24 to what point? So what you're kind of listing out, it starts at 0, 0, and then it maps the point. Whoops. It maps the point 4, -16 to the point 1, -4. So all they're doing literally is dividing by 4. So on number 22, you just have to take this and divide by 4. This is something a lot of people will overthink, but the answer is just going to be F. Sometimes simpler is a little bit better. So on number 23, a cleaning company sends out advertisements to the potential customers. The table lists the probability of an advertising link to a certain amount of revenue to the nearest cent. What is the expected value of the revenue generated from an advertisement sent to the potential customer? So this is a lot of probability here, and you've got to do a little bit of averaging. So we have pretty much, you can make this a probability of 100. And then the easiest way would be to go 2 times 400, which is 800 plus 200. If you go that 2 times 100, and then you would go 4 times 60 plus 240. And then $0 is the rest of it, plus 0. So if you add up 800 plus 200 plus 240, and then divide it by 100, it is going to be $12.40. They do a lot of these applied probability ones, but once you recognize them, they get a ton easier. Okay, so you have a distribution here. You've got your x variable. So pretty much which one of the following values is the value of going from this interval to this interval. So what we're looking at here is this all the way, which is the value of this. So we're trying to find out the percentage likely of this. So statistically, in a normal curve or bell curve, you're going to have 2% here, and it's going to be pretty much a mirror. So out of 100, you would go 100 minus 34 minus 34. And then you would go minus 2, minus 2. So all you're left with is 28%. And so then you divide by 2, so that's 14. So this one is going to be 14% because it is like a mirror. On number 24, this is where I swear by the calculator programs here. All you have to do is you just have to plug it in. I've got it linked in bio, and it pops out exactly as you follow along as I enter in the digits here on the screen, exactly the 323rd digit to the right of the decimal place. So at number 25, the answer is going to be 1. There is an annoying way to do this. It confuses most students. Honestly, just get the programs. Even if they're not mine, highly, highly recommend them. So number 26, Javari's walking around the straight sidewalk. So right here is kind of like fluff. So you're going to see me skip a good bit. So let's figure out what we're going with based on Javari's estimate. Which of the following expressions represents the height in feet of the tree? So instead of me just straight reading down, I start skipping around to figure out what I am actually solving for. So we've got a tree. It's obviously a terribly drawn tree. And he is walking, and then he sees a tree directly ahead of him. Here's our friend here. He estimates the elevation is 25, so you can tell we're working on a triangle. And then as he continues walking, he finds that it's about 45 feet from the base. And now he wants to estimate the height of the tree. So right here, you've got good old SOHCAHTOA. I actually have a really short video going over this. We will link it below so that you can review SOHCAHTOA. On this particular one here, remember we're focusing on this tree right here, which is going to be opposite. So the values we have and the values we're looking for is we're looking for opposite. We have adjacent, so then we need to use tangent on number 26. And I don't have to do anything else, and I just know it's tangent. Okay, so on this one, this is talking about a small hole with leaking. So given that the sugar weighs 0.025 pounds per cubic inch, which of the following values is closest to the amount of sugar that was left in the bag after it leaked? Which would be rather inconvenient, to be honest. So on this one right here, you have 1.5 pounds. And then it is forming this formula of a cone. So what you have to do on this problem here is we just have to plug it into the cone. So we've got V equals pi over 3r squared over h. So then if we're going to find the volume, we go pi over 3. It gives us the radius of 3, so b squared times 2. And then we will find that number. So this is a good reminder of when you have your calculator do all the work. I have people that will try to do this in their head, and it's really unproductive at that point. This is a time test, so you have to be conscious of that. So you will go the pi times 3 squared, and then you go times 2. So that's going to be a ballpark about 18.84. And then it gives us this weight, so then we just have to multiply it by 0.205. Or I should say 0.025. So that one is going to pretty much say that 0.471 was leaked out. And then you have to subtract it from 1.5. Which on that turn, it's going to be B, which is going to be 1.029 on number 27. So on this problem right here, this is going to be an expanding term problem. And as we move forward, these are going to get harder and harder. The resulting terms will be arranged in descending power. So after these steps done, the second term will be this. What will be the total number of terms in this problem? So on 28, it's pretty much wanting to FOIL out a good bit. And one thing that you want to note here is you have x to the power of 3, and that is going to be the second term, so it is likely going to be a little bigger. So let's start working through these. So we go x plus by, and we'll go ahead and square it first. And I can tell you right off the bat, with only to the power of 3 as the second term, you're going to want to go ahead and eliminate c and d. So if we assume okay, so we're not going to worry about the numbers here. Likely B is going to be 2 just looking at it, but let's go ahead and just kind of multiply it out and see what we've got going on. So that would be, if we're foiling it, it would be x squared plus this would be, let me make sure we put a bxy plus bxy, which we know we combine like terms, plus b squared y squared, and then that'll be x squared plus 2bxy plus b squared y squared. And this is just a really tedious problem here. So we know that after these steps, what will be the total number of terms? This is only 3 terms when you square it. So here's the kicker. We've got to decide if it's going to be 5 or 8 terms. So if we go ahead and do it to the power of 3, x plus by, and then this is a little bit of a beast, so it takes a little bit of time, but you have to go x cubed, and I'm going to try to find a good stopping point on this. And then, yeah, so that'd be x cubed plus 2bx squared y plus b squared xy squared. And then you would do it with the other terms. So that would be x squared by plus this would be 2b squared xy squared. And this stuff is super tedious. Plus b cubed y cubed. So if you go ahead and look for like terms on this one, what I am seeing here is going to be, I see an x cubed, then we go plus, I like to cross out my legs, right? So the last term is definitely going to be plus b 3y3, and so those 2 terms are covered. And then we've got to see what other terms we can match here. So that's going to be 3b squared xy squared, and then that's going to be plus 3bx squared y. And like I said, these are just messy. But if you look at this, if this is the second term, and then there's 4 terms, and you're adding terms each time, you're gonna hit that x cubed on the next FOIL, so the answer on this one is gonna be A. If you have a faster way to solve it, I would be interested. I know I'm taking this the slow way, but I know there's some faster ways, and I'd be interested to hear what you've got. And you can drop that in the comments there.
Okay, so for number 29, there is honestly a lot of distractions in here, but what you need to focus on is just kind of a couple of things. So I tend to skim. So which of the following identifies the best type of functional model for the data representing the 12-hour interval? 12-hour and gives a valid reason why the model is best. So what we're looking at is linear and exponential. So linear, just a reminder, is a straight line. Exponential is going to be more of a curve. So on this particular thing, I'm gonna just kind of draw out a graph. So at T0, the concentration is equal to 850, and T6, the concentration is equal to 151. And then, so it looks like it's decreasing from there. So I would just kind of simplify this and see if we can make it a little bit bigger. So you've got, we'll just go by hundreds. So that'll be 900, 800, 7, 6, 5, 4, 3. So let's erase that and start over. So let's make this a little bit bigger. So we'll put 9 for 900, 8, 7, 6, 5, 4, 3, 2, 1. And of course, they're not perfect, but you can still get the gist just from doing these basic ones. And then our time is kind of spread out over what you have over here is going to be 12. You got your 6, and then you got your 0. So where this is starting at for the 0, or use a different color, is about up here. And then what happens for that at 6 hours, it is about 151, which is way down here. And then down here by 12, what you were looking at is really, really close to that zero at this point. So on number 29, we know that it's decreasing. And since it's a curve, this is going to be exponential. So the answer is going to be H. So on number 30, we know that n is a rational number. Which of the following statements about the number with this crazy equation must be true? So what's kind of easier on this is just make n equal to a rational number and go ahead and test it out. So let's pretend that n equals 2. And in theory, it should work really with any of them. So what we can do here is we go -4 square root of 14 minus 2 divided by 12. And when you put it in your calculator, because you have that square root of 14, you are going to have a crazy, crazy decimal. So you go times -4 minus 2, and then divided by 2. That's going to be a decimal that's not repeating. That's not crazy. So in number 30, the answer is going to be C. It doesn't really matter what number you plug in, but knowing what a rational number and an irrational number is going to be the key. So number 31, people kind of panic because they don't recognize this, and this is honestly an ellipse. It's like an oval. You don't really have to know much about it. You just have to use common sense to figure this out. So we're looking for the x-intercept, and we have a lot of hints right here, and actually right here too. So the only one that is next to the x on this is going to be a 9. And we also know that we have a squared right up top. And of course, you can solve for it. It'd be a pain in the butt. There's certain programs you can put in your calculator, but they take a long time. But if you just kind of know process of elimination. So if you have things under the number on the ellipse, automatically it's not going to be a 0, 0. If you know your circle formula as well, you'll understand that. So we're going to eliminate F. We'll go back to G. H, 7 is only related to the Y because of this 49. So we're going to eliminate that. And now the only two logical options left are 3 and 9. But since the squared is here, we want to square it or square root it. So the answer is going to be G. So on number 32, one of the following is the equation of the graph in this coordinate plane. Which one? So honestly, you can do these like by hand. You might lose your mind on this. All you have to do is plug this into the graph. Here's my hint. If they're giving two log options, likely it's going to be one of the logs. And so all you do on your graphing calculator is plug it into the y equals and graph and match. So one key thing to know on the graphing calculator is this math button. You need to make sure you are changing the log base, which is going to be A, 4, and then x minus 4. I'll go ahead and put in C, and then we can go ahead and put in D too. So we go 4 log change base, 4, and then we'll go x plus 2 plus 4. And then let's go ahead and graph it. And from there, you will be able to see that just by matching graphs, D is going to be your correct answer. So number 33 is something people get confused with a good bit, but let's try to simplify it. So event W consists of 14 simple events. Event X consists of 11, none of which are in event W, and Y is the intersection of events W and X, and the Z is the unit of the events W and X. Which of the following statements is true? There's a bunch of malarkey in this one. So let's kind of just state the facts. So W consists of 14 events. So let's just go W equals 14. X consists of 11. So we got those two right off the bat. One thing that we are noticing is that X is smaller than W. So what I always do is if ever I'm stuck, I do a quick check to see if any of that is on there. And no, there's nothing we can eliminate at this point. Y is the intersection of events W and X, and Z is the union of events of W and X. So looking at number 33, what you want to focus on is what union is actually. And union just means pretty much addition. So if we go 14 plus 11, that is going to get us 25. So right now we know which is equal to Z. And the intersection, I wouldn't stress about it right now, but let's just focus on these three terms right here. So 25 is going to be the biggest. And so we want it to Z to be the end. And then then you've got W, and then you've got X, and then the other options. G and J don't make sense because of Z right there. So now we are down to event Y is the intersection of events W and X. In the simple terms of intersection is at this point, I would focus just on the difference of this one. And so this is going to make, on this example, number H the correct option. On number 34, an isosceles triangle, which has a bunch of details I am not going to read through, but pretty much it's kind of like a puzzle. So what they're looking for is the ratio of ABC to the area of this. So let's just kind of talk about it realistically. You can, and I've kind of played around with like kind of just breaking down the numbers, but let's think about it this way. So A, B, C. Let's pretend this area is going to be 10. And then our goal is to look at this tiny one, F, G, H. So what is happening between A, B, C, and let's go to the next triangle, which is D, H, E. If you're looking at it and just looking at proportions, there is 1, 2, 3, 4 sections, so it's going to lose a fourth. So if we just go 10 divided by 4, this is about the area is 2.5. And then if you look at it, this is also going to lose a fourth as you're going to the smallest triangle. So on number 34, the most logical answer is C. The first time I solved this, I tried to make it way more complicated. And I was actually a student who kind of showed me that. I'm like, oh, that's so much easier. Even if you do math like all the time, like I do, sometimes we overcomplicate things, but try not to on this test if you can. So 35, and I promise we're almost done. Two perpendicular lines in the standard XY coordinate plane have non-zero slopes. What is the product of their slopes? So let's just kind of pretend. It doesn't really matter which one. So we're going to go line 1. We're just going to call it non-zero slopes. We're going to call it -2. And my line went absolutely crazy. And then remember perpendicular lines, it's the negative inverse, but pretty much you flip it and you change the sign. So let's go line 2 is going to equal 1/2. What is the product, which is a good math term, which is times of these two? So then you just go -2 times 1/2. And your answer is on 35 going to be B, -1. This will work for a variety of numbers, but it's easier just to see this with real numbers. So 36 is another good example of plugging in numbers for integers m and m such that -3 is pretty much m's between those two numbers and n is between those two. What is the greatest possible value of n minus n? And remember, that's an absolute value sign, which anything you put in an absolute value sign comes out a positive. So we have to figure out what is going to be the biggest possible combination here. And since you have the absolute value sign, that does change a lot of things. So what I would look actually on this one here is 36. I would actually choose 4. And then we go minus n, and I would choose the biggest number there is 10, -10, so go -10. And so that would be 4 plus 10, and then so the answer would be 14. 37 is this formula here. What is the value of C? So this is where it gets to be a little bit annoying, but not terrible. So you have this formula right here. We know that one of the factors that we are pulling out, x squared minus 30x plus c, is if you're foiling this, they're saying that x plus 4 is going to be one of the options here. So here is one thing to think about. Is you want them to be divisible by 4 or some form of factor related to 4 on the answer. So I'd actually work backwards. So on 37, if I was stuck, this is what I would do. I would go like negative 160 can be divisible by 4, so A is okay for now. Let's go 26. We know it cannot be divided by 4. That's going to be ugly, so that's not going to be a clean number. And yes, you could argue that there's that there, but that's kind of irrelevant at this point. This can be divisible by 4, and then 110 cannot. So now we've eliminated two options. So even if you're stuck, if you can eliminate it down, then it helps a good bit more. So one thing to think about here is now we are stuck between two options only, but here's the big but. We do not have a negative here. And we have a negative here. And if we know foiling, F-O-I-L, really, really well, then we know that we need a negative sign. So 37, the answer is going to be A. On number 38, a company designed a questionnaire to be completed by its employees. The questionnaire has 5 questions with the answer choice of yes or no. Given that every question must be answered, an employee can only choose one answer to each question. And how many ways can an employee answer all 5 questions on the questionnaire? Woo Nelly, that is a lot of options. So on number 38, you've got a lot going on. So you've got 5 questions. You got 1, 2, 3, 4, 5. And then they have 2 options on each of these. 2, 2, 2, 2. And what we have to remember is that we multiply options together. So all you have to do is you multiply these together, making this answer on 38H. Now is a good time. If you have any specific questions or videos that you want to see, even one, I've been debating about doing one on foiling, and maybe that'll be done by the time you see this. Let me know in the comments. I would love to hear from you guys. So on number 39, consider quantities A, B, and M, given that 40% of M is equal to A, and B is equal to 7A over 10. Which of the following expressions gives 112% of M in terms of B? Which honestly sounds like a bunch of malarkey in the beginning, but we've got to hack through this. So given that 40% of M is equal to A, and so whenever I look at this, I'm like, okay, we need to define terms. You're gonna learn that I love putting in false numbers. It just helps clarify things for many kids. So let's go ahead, given that 40% of M. Oh, I missed a variable there. So let's go ahead and make up a number. I like using 100 because it's just a little easier. So we're going to pretend that M is going to be 100, given that 40% of M is equal to A. So 40% of M is going to make A 40. And then B equals 7A over 10, which the following expressions gives 112% of M in terms of B. So let's go ahead and solve for B. So we go B equals 7 times 40 divided all by 10. So B is going to be equal to 7 times 40 is going to be equal to 28. So at this point, now we have to figure out how on earth we're going to make this make sense. So 112% of M in terms of B. So let's just find out what 112% of M is, which you probably can just math it in your head is 112 equals M. And then what is the factor related to B? So if we go 1/12, just divided by B, it's going to be 28. And then on this one right here, if you go that 112 divided by 28 is going to be 4. And then you got to use a little bit of logic and reasoning here, but to know that on 39, your answer is going to be 4. This is really theoretical. The SAT also likes this a lot too, but honestly, I used to spin up with these really badly, but once I started just using like real numbers, especially just starting with like a normal number like 100, I have some kids that use 10, whatever, but this helps a lot. Okay, so for number 40, they are building off of this formula, which is a sum of the first in positive integers. And this is pretty fringe. If this is something you don't know and you're trying to improve your score a good bit, it's not something I would like hyper focus on learning. But if you are trying to get into the 30s, this could be helpful. So what they're focused on here is the pretty much the sum of the integers, which this one, they kind of give it to you. But what you do from this point is n is going to be the number, so that's going to be 75. And then we go 75 plus 1, all divided by 2 into our formula. 75. And then, so that would be 75 times 76 divided by 2. So the answer on this one would be J. What are the equations of all the asymptotes in this coordinate plane? So asymptotes are going to be kind of like your holes in your graph. And the simplest way to do it is to use your graphing calculator, which I think we all know how I feel at this point about graphing calculators. I love mine. I even have two, which is a little excessive, but that's okay. So what you're doing is you're just going to type it into your y equals area. This is something really good to practice, even on the more simpler problems. And then you make sure you graph it. And from the graph, you're kind of looking for these big holes, which is covered a lot actually in most algebra 2s. But what you're seeing consistently on the graph is you have a hole here, space here, and space here, making this answer D.
So hopefully you learned something new in this video. I would love to hear in the comments about what you learned or maybe what you need better support on. What I have linked in the description is the link to purchase our ACT Calculator Companion programs. These are downloadable for your TI-84 Plus calculators. They do semi-work on the TI-84 regular, but they are super, super helpful and they are allowed on the ACT. It is written with the ACT guidelines in mind. So if you want to download those, check it out. If you need some one-on-one support or want to join our online community, that is linked below. But regardless, good luck, and I hope you knock your next ACT out of the park.